Lesson 3.1, Understanding Proportional Relationships. Our goal today says, I can graph a proportional relationship from a story, and I can use the constant of proportionality to compare the pace of different animals. Recall that the constant of proportionality uses this equation right here, y equals kx. Let's take a look. Here we have a ladybug and an ant moving at constant speeds. The diagram with the tick mark shows their positions at different times, and each tick mark represents 1 centimeter. So we look here, the ladybug and the ant are starting at 0, and that is no time going by. After 2 seconds, you can see that the ant takes the lead. After 4 seconds, you can see the ant is even further out front of the ladybug. And at 6 seconds, you can see the ant and the ladybug in their positions. So question 1 is on the second page of your packet. So go ahead and pull those apart so you can see the question and the graph at the same time. I put my graph below the question. We're going to create a graph to model the movement of the ladybug and the ant. We're going to use, there's a typo, that should be E. We're going to use the x-axis for time. So let's label time on our x-axis, and that's in seconds. And we're going to use the y-axis for distance in centimeters. So go ahead and label that distance and centimeters. Okay, so now we're going to use our data and plot our points. Okay, I'm going to make my ladybug in red, and I'm going to start with that information. So I'm looking back at the chart that we started with. At 0 seconds, the ladybug is at 0, so I'm going to put a point at 0. And then when I look after 2 seconds, it looks like the ladybug has advanced 4 tick marks. So after 2 seconds, the ladybug is at 4 centimeters. At 4 seconds, I count the tick marks, and the ladybug has advanced all the way to 8 tick marks. So 4 seconds, 8 tick marks, or 8 centimeters. And finally, after 6 seconds of time, it looks like the ladybug advanced a little bit more out to 12 tick marks. So over 6 up 12. And then I'm going to neatly connect those points. Next, I'm going to select a different color for my ant. So if you want to use a pen and a pencil, somehow try to distinguish that on your graph. And let's plot the ant's progress. So again, at 0 seconds, the ant is at 0. After 2 seconds, if I count the tick marks, it looks like the ant is out about 6 slots forward. So at 2 seconds, we go over 2 and up 6. Okay, so I just counted right in there how many tick marks. Okay, now after 4 seconds, the ant has jumped all the way to, from here to here, that's 12 tick marks. So over 4, up 12. And finally, at 6 seconds, the ant is all the way at 18. So over 6, up 18 is going to make me fall off the graph. You can maybe hover a point above there. Okay, let's neatly connect those points. Okay, now question number 2 says, how long does it take the ladybug to travel 12 centimeters? So now we're going to look at our graph. I put it right here on my page here. So you go back to your first page and look. So 12 centimeters, how long does it take? So how much time does it take to go 12 centimeters? So here's 12 centimeters on the graph. And the ladybug is in red. So I'm going to go across to see where that hits, and then go down to read the time that it takes. So we're going to answer this question as 6. It takes the ladybug 6 seconds. And then it asks how long it takes the ant to travel 12 centimeters. So I go back to the 12 centimeters, and now I'm looking for the ant, which is blue, and then read down, and it's 4 seconds for the ant. And then we go ahead and answer that. So the ant takes 4 seconds. Okay, so that's question number 2 done. Okay, now we're going to mark and label the point on the line for the ladybug and the point on the line for the ant that represents the time and position after traveling for 1 second. So where are they after 1 second? And we're going to mark that. Okay, so let's go back and look at our graph. Okay, so after 1 second, where are they? So let me get a different color here. I'm going to go green. Okay, so after 1 second of time, where are they? So it looks like right about there and right about there. 2 and 3 is where they are. So mark that on your graph. Okay, next section is called moving twice as fast. So we're going to think about what that means if something is twice as fast. We're going to refer back to the tick mark diagram and the graph for this. Number 1, imagine that a bug is moving twice as fast as the ladybug. On each tick mark diagram, mark the position of this new bug. Okay, so twice as fast as the ladybug. All right, so in the beginning, our new bug would still be at 0. I'm just going to make like a little smiley face. Okay, so now twice as fast. So our ladybug on our first graph went ahead 4 tick marks. So if we go twice as fast, that would be 4 and 4, which is 8, or 4 times 2, which is 8. So starting at 0, I'm going to jump ahead 8 marks. 1, 2, 3, 4. That's the ladybug. 5, 6, 7, 8. There's my new bug right at 8. So let's put our new bug right at 8. Okay, let's go on to what happened after 4 seconds. So our ladybug after 4 seconds is at 8. So if we go twice as fast, we'll be at 8 and 8, which is 16. So move ahead. 1, 2, 3, 4, 5, 6, 7, 8. Twice as fast means 8 more. 9, 10, 11, 12, 13, 14, 15, 16. Our new bug will be at 16. So we put our new bug there. You can make your bug, with antennas or whatever you want to do. And then finally, our last ladybug, after 6 seconds, our ladybug made it to 12 centimeters. So we would double that, because we're moving twice as fast, so we'd be at 24. So count forward 24, 1, 2, 3, 4, and all the way out to 24. So our last bug goes all the way out to 24. So go ahead and mark your bug on your cover page, and everything is twice as fast as the ladybug. Okay, moving on to question number 2 in this section. We're going to plot this bug's position on the coordinate axis with lines and connect them. So we're going to put our new bug on here. So he's already green. So in your answer key, we'll put our new bug on here. And he starts at 0, 0. And then after 2 seconds, our bug was out at 8 centimeters. So over 2, up 8, put a new point. After 4 seconds, our bug was at 16. So over 4, up 16. I'm off the graph, but I'll hover just right there. And then after 6 seconds, our bug was way off the graph at 24. So let's just connect the 3 points nice and neatly. And I just drew an arrow to show that that point falls off the graph. So you can see our new bug is actually faster than the ladybug and the ant because it went twice as fast as the ladybug. Okay, so our last step is to write an equation for these lines representing the ant and the ladybug. So remember, we talked about 7th grade, our formula for the constant of proportionality. y equals kx. So what we're going to do is fill in their speed, the constant speed that they're going at for each one. So let's take a look at our ant, and my ant was in blue when I look at the graph. So if you go back and look at the graph, so the ant, after 1 second, is, let's see, the ant is right there at 3. So that's the speed. It goes 3 centimeters in 1 second. So we put our 3 in for our constant, our speed. So our equation would be y equals 3x. The ladybug, after 1 second of time, travels 2 centimeters. So our ladybug equation would be y equals 2x. And then our new bug, if you remember, was twice as fast as the ladybug. So our new bug, and you're going to put it on that line right there, our new bug is twice as fast, so that is 4x, which is also on the graph. The new bug, after 1 second, travels 4 centimeters per second. So to write the equation for the constant of proportionality, we use their speed. So 2 and 3 and 4. Okay, and then as a follow-up, we want to give you a few minutes to try to practice some of these graph activities on your own. So please try problem 1 and 2 on the back of your packet. So it reads that Pyra, I think, jogs at a constant speed, and the relationship between her distance and time is already shown on the graph. So you're going to put Diego's speed. He goes twice as fast as Pyra. So you're going to try to sketch Diego on the first graph. And for number 2, you pick blueberries at a farm, and it offers 6 pounds for $16.50. So sketch a graph there to find pounds, how much it would cost per pound. So for 6 pounds, we know it's $16.50, so you want to try to make a graph here as well. Good luck.